Welcome. We're going to be talking about survey research again, and in particular, we're going to talk about reliability and validity. The objectives for this presentation are, first of all, to describe the types of instruments you might want to use, describe the various types of validity and reliability, and then talk about choosing or designing an instrument to measure your particular interests. Now, when we think of quantitative data, one of the terms you hear all the time is a variable. Well, what's a variable? A variable is a construct that can be measured. So say, for example, if you think of something like intelligence, well, you know what you mean by that construct, and you know the people who you think are highly intelligent. So we have to come up with a way to measure it. More simply, if we talk about height, that's another variable we could measure. Well, what's measurement? Measurement is the process of assigning numbers to individuals, objects, or events according to rules. So if we're talking about my height, I am 5 feet 5.5 inches, and the way we assign this number to me, 65.5 inches, is by knowing the distance of 1 inch and then measuring the inches from the bottom of my feet to the top of my head, and that's my height. So operationalizing a variable is defining how the construct or variable is to be measured. Now we have several types of instruments. Generally they fall into two categories, verbal and performance. And verbal instruments are those that require respondents to either read items or to have questions read to them. Paper and pencil tests are an example of verbal instruments. The STAR test you give your students are another example. On the other hand, performance instruments are those that require the respondents to do something, to actually execute some sort of behavior. So say, for example, I wanted to be a licensed lifeguard. Well, I would have to pass a swimming test. I would have to demonstrate certain swimming behaviors. Furthermore, we can say that instruments can be divided into tests, and tests require correct responses or mastery of some type of information. Scales, and scales are self-report instruments with correct or preferred answers. So, for example, the Beck's Depression Inventory would be one. We know that we prefer people not be depressed. Inventories, although people don't always use these terms that way because of Beck called his an inventory when it was actually a scale. Inventories are surveys, are self-report instruments with no correct or preferred responses. So say, for example, if you were given an instrument about your career preferences, well, there's no perfect answer. There's just what you would prefer to do for your career. And finally, we have observations. For example, observations of what our students are doing or observations of someone swimming. These are other types of instruments. Now, the content of instruments is also something we want to think about. And instruments can be divided into several different kinds. Achievement or cognitive instruments measure knowledge or mental functioning. Aptitude and ability instruments measure people's potential and strength. Psychosocial affective measure personality traits. Interest and opinion measures people's beliefs or attitudes and values. And finally, behavior and motor skills instruments measure some kind of observable behaviors. Well, when someone is measured with an instrument, how do we know that their measurement that we got was right? Well, there is classical measurement theory, and this says an observed score, which we have indicated here with O. So if you take, for example, an intelligence test, your observed score is equal to your true score, T, plus error, which is E here. So how many times have you taken a test and you said, oh, that test really didn't measure what I know? Well, that part, what you didn't know, is error. So ideally, our observed score would be exactly equal to our true score, and error would be equal to 0. But that's not always the case. Sometimes we score better than what we should, than our true score is. Then we have positive errors. And sometimes our observed score is lower than our true score, and so the error is negative. Well, we can expand this to say that the variance, sigma squared, of the observed score is equal to the variance of the true score plus the variance of error. And reliability, in our last line here, R sub xx, the correlation of an instrument with itself, is equal to the ratio of the observed score error variance to the true score variance. Well, think of what this means. If your observed score was really, really close to your true score, then error would be really close to 0. Okay, doesn't that make sense? If your observed score was close to the true score, then there is no error. Well, then your error variance would also be close to 0, and the variance of the observed score would be very close to the true score variance, and the ratio of those two would be approaching 1. So you'd have a high correlation here. There are several types of reliability. Test retest is when a group of subjects are given an instrument, a certain amount of time passes, then they get the same test over again, and then we correlate the pre-test with the post-test and hope people don't remember items too much. Sometimes we have two forms of the same instrument. So here participants are given both forms fairly close in time, and then the scores for those two forms are correlated. This is called equivalent forms, and a little bit of a problem here is that we actually do have different items on these two tests. Sometimes we don't have the luxury of giving an instrument twice, and we don't have two forms of the test. So in this case, we have to calculate internal consistency reliability, which simply means that all the items on the test or the instrument are measuring the same thing. We have several kinds of internal consistency. Split halves, we divide the test and take one half of the items and then the other half and correlate them. We have Cooter-Richardson, which are, there are two formulas, one for dichotomous true-false items and one for multiple choice items. And here we are using a formula based on on the variance based on all number of items. And under certain conditions, Cronbach's alpha will give us the same thing as a Cooter-Richardson. We also have inter-rater reliability for when there are observations and we want to make sure that different observers will agree. For example, we want to make sure that both observers who are looking at our swimmer will agree that the person is really strong enough to become a lifeguard. And this can be calculated either with a correlation coefficient or with percent of agreement. There is a newer kind of theory, newer than classical measurement theory, and this is item response theory. And this is a different way of coming at reliability. And this determines the probability of a correct response, which is a mathematical function of person and item parameters. And it doesn't assume that all items have equal difficulty, like classical testing theory does. And if you think about it, most tests that you've taken, probably the items are different. Some are more difficult and some are easier. Another thing that item response theory can do, it can look and see if people, for example, if males and females respond to the test in the same way, or members of different ethnic groups respond in the same way. So this is one way that tests can be examined to look for bias. There are several types of validity, And whereas reliability gets at the accuracy of a measure, so if we measure something twice, will we get the same number? Validity asks if the test measures what it says it measures. And there's several types of content validity, or validity. Content validity is the first. Here we create a matrix of the content we want to know and then determine how many items we want to have. For example, if I have a math test for young children, I might have like 2 plus 3, 3 plus 4. Those are probably similar items. Those items are different from 5 plus 7, where now our answer is a 2-digit number, or 7 plus 15, where we have to carry. So we want to think of what our content is and then decide how many items we will have for each one. Face validity is used when we really don't have any way to assess other validity, except we're going to look on the face of it. Does the instrument look to be valid? For example, we had a student here who wanted to study the effects of incest, and she looked and couldn't find any instruments that measured this, so she developed her own. And there were no other instruments for her to correlate hers to. So she asked a series of psychologists if they thought the instrument was valid. And the instrument measured different things like trust. Were you able to trust people? Were you a little bit dissociative? Your comfort level. So various aspects of things you would expect someone who would experience incest to be going through. Criterion-related validity is calculated by correlating your instrument with some other well-accepted instrument. For example, if you developed an instrument of depression, you might correlate yours with the Beck's Depression Inventory. Since they measure the same thing, if they correlate highly and positively, we say the instrument is valid. If you correlate your test with an instrument in the future, then we say it has predictive validity. If you correlate your instrument with an instrument administered at the present time, then we say you have concurrent validity. Finally, construct validity has to do with the ongoing process of making sure that an instrument really measures what it says it measures. And let me give you an example. Some of you may be familiar with the MMPI, the Minnesota Multiphasic Personality Inventory, which has, I believe, 557 true-false items. There are lots of subscales. Usually people don't get all that 557 number of items. But anyway, there was an item on this test that said, I like to take a bath, true or false. Well, I know a lot of people who are very clean but haven't taken a bath in years, because socially now we tend to take showers more. So they revised this instrument to say, I like to take a bath or a shower, true or false. So we can look at how the construct changes over time. And we have convergent validity. This is where two instruments measuring the same thing, for example, two instruments measuring depression, should correlate highly and positively. And discriminant validity, where two instruments measuring the opposite construct, for example, depression and happiness, correlate highly and negatively. Well, what do you do if you want to choose an instrument, or you want to, you're trying to measure something? First of all, you want to match the purpose of your study with the design of the instrument. And there's several practical and technical considerations here. We already talked about the reliability and the validity, the logistics of test administration. If you want to administer a 557 item instrument, well, then I wish you good luck. I'd say most people won't finish that. We also want instruments that are culturally sensitive, and sometimes cost is a consideration. Some instruments you have to pay for example, the STAR test, others are free. There are a lot of resources to help you find instruments. If you're looking for scholarly instruments, I would really suggest the Mental Measurement Yearbook and Tests in Print at the Burroughs Institute. Here's a URL for it. And there's also, I've listed several popular sources like Queendom, Nerd Tests, and all the tests. Those are kind of fun to look at. If you are developing an instrument, then you, first of all, I would really suggest trying to find an existing instrument. This really saves you a lot of time and effort in developing one. But if you can't find one, or if you just want to write a survey for your own specific purposes, then first of all, determine the purpose of the instrument, define your objectives, behaviors, or constructs that you want to measure, create a measure of the content considering item difficulty, complexity, and the percentage of items that you want within certain categories, or the percentage of items that will gather information on certain topics. Then you're going to start writing items according to the matrix. It's really important that you field test the instrument. Most people will revise theirs once they field test it. And finally, calculate your reliability and validity. So, have fun.